For number 33, we'll be graphing an exponential function, and it says to use transformations where appropriate. Look on page 271 of the book. It's the end of chapter 2.7. It talks about when a graph will be shifted left or right or up or down or stretched. And so graphing an exponential function, kind of your starting point, if it hasn't been transformed at all, you know that when x is 0, the y value is going to be 1, because no matter what the base is, whether this was 4 to the x or 5 to the x or 2 to the x, no matter what the base is, if the exponent is 0, the result is 1. So no matter what the base is, you always have the point 0, 1 on the graph. And then when the x value is 1, you always have the value of the base, because 4 to the first power is 4. If it was a 5 and you had 5 to the first power, you'd get 5. So, and so on. So when x is 1, your graph is going to be at the value of the base. So for this graph, 4 to the x, we'd be at the point 1, 4. So now you just need to know how every point is going to be transformed based on this plus 1. And an addition inside the function like this is going to be a shift to the left. And that's what we see here with choice A. Instead of the point 0, 1, we have the point -1, 1. And instead of having 1, 4, we're going to have 0, 4. And so just seeing those 2 points shifted, and you can notice that every other point is also shifted 1 to the left. A is identified as the correct graph. A couple of other shifts, just to throw these in here for reference. If the 1 was outside the function like this, so you have 4 to the x, and then you add the 1, that's a shift upward by 1. And just to show a stretch, you'll get a stretch when you do multiplication. So if you had some number multiplied by the function, that would stretch the function.